Hello everyone, welcome back to the video. And we continue with the recitation video where we talk about the trapezoid and the Simpson rule. So for this question, the question wants you to do the integral. Uh, the question gives you the integral and you cannot find the entire derivative. And the question wants you to use the numerical integrations, which is given by the left endpoint rule, the trapezoid rule, and the Simpson rule to approximate the integral. So let's try. And for the problem that I'm gonna cover in this video, instead of using sine of x squared, I will use cosine of x squared. Okay, firstly, the thing I want you to do is you have to compute the length of your discretization. So the main interval was from 0 to 1, and all of the numerical integration want you to use L4, T4, SF4, so the length of your discretization will be delta x equal to b minus a divided by 4, and b is the right endpoint, which is the upper bound, a is the left endpoint, which is the lower bound. Okay, therefore I have 0.25. Okay, so from here, you have to initialize your input. So x of 0 will be 0, which is a left endpoint. And then because the length of discretization is 0.25, the next input will be 0.25. Okay, the next input will be 0.5. Sorry, 0.5. The next input will be 0.75. And the last input will be 1. Okay, because the question just wants us to use L4, T4, and S4. Okay, so for the left endpoint approximation, okay, remember that for the left endpoint approximation, that means you're going to use the rectangle, okay? You're going to use a rectangle, and to compute the areas of each rectangle, you're going to take the base multiplied by the height, but the base is the length of your discretization, which is delta x. For the left endpoint approximation, the height of your rectangle will be given by the output of the function as the left endpoint. Okay, so that means over here, this is this is the base for your first rectangle. Is that correct? You're gonna use 4 rectangle to approximate your integral. X0, x1 will be the base of your first rectangle. Therefore, the integral that you want to evaluate, which is cosine of x squared dx, will be the base, okay, multiply with the height of rectangle. So this is the base of your first rectangle, the line that connects x0 and x1. And for the height of the rectangle, it will be given by the output at the left endpoint. So that means I'm going to use f of x0. Okay, and then, so this is the areas for the first rectangle. You're going to continue with the areas for the next rectangle. So for the next rectangle, that the base of the next rectangle will be the line connects x1 and x2. Okay, so the length is still 0.25 for the base. And for the height of your rectangle, it will be given by the output of the function at the left endpoint. So I want to check delta x multiplied by f of x1. So similar for the next rectangle, I'm going to use the base, which is x2, x3, and the left endpoint will be x2. So I will take delta x multiplied with f of x2. And finally, for the last rectangle, I would take delta x multiplied with f of x3. And remember that when you use you want to use 4 rectangles, so you have 1, 2, 3, 4. So you are done. So remember for the left endpoint, approximation, you will not use the output at x4 at all. Okay. And now you factor delta x. You have f of x0 plus f of x1 plus f of x2 plus f of x3. Okay. Delta x is 0.25. F of x0 is f of 0. F of x1 is f of 0.25. F of x2 is f of 0.25. F of x3 is f of 0.5 and f of 0.75. Okay, and now you just need to plug in. So 0.25 cosine of 0 square plus cosine of 0.25 square plus cosine of 0.5 square and cosine of 0.75 square. Okay, the function is cosine of x squared. So you just need to replace x by these input. So cosine 0 squared, cosine 0.25 squared, cosine 0.5 squared, cosine 0.75 squared. And using calculator, you can simplify your calculation. Okay, how about the trapezoid rule? For the trapezoid rule, remember that this one is approximated by left L4, which is this one. So for the trapezoid rule, you will do the same thing, but instead of using rectangle, you're going to use trapezoid. So T4, and remember that the formulation for the trapezoid rule is this one. Sorry, let me copy down this one again. This is the formulation for the trapezoid rule. Okay, so you're gonna have delta x divided by 2. So write down delta x divided by 2 multiply by, remember that for the trapezoid rule, the first and the last one will have coefficient 1. The middle terms will have coefficient 2. Okay, so I have f of x0, which is the first terms, and I have f of x4, which is the last terms. And for the middle terms, I have 2f of x1, 2f of x2, 2f of x3, and then we have the trapezoid rule formulation for T4. Okay, and now we just plug in stuff. Delta x is 0.25 divided by 2. F of x0 is f of 0. 2f of x1 is 2f of 0.25. 2f 0.5. 2f of 0.75. And f of 1. Okay, x4 is 1, so f of x4 is f of 1. And now you just plug in the input into your function. Your function is cosine of x squared. Okay, I forget to write down dx. Okay, so you have cosine of 0 squared plus 2 cosine of 0.25 plus 2 cosine of 0.5 plus 2 cosine of 0.75 plus, I'm sorry, I should have square, and cosine of 1 square. Okay, and again, you can use your calculators to simplify to get the final result. Okay, for the Simpson rule, this will be the same thing. And let me copy down the formulation for the Simpson rule. This is the formulation for the Simpson rule. Okay. So, okay, this is the formulation for the Simpson rule. Okay, this is formulation for the Simpson rule, and the only thing you need to remember is you have to determine the index n that you're going to use. So for this question, you're going to use 4. Okay. The first terms and the last terms will have coefficient 1. For the middle terms, you will alternate between 4 and 2, but remember you will start with 4. Okay? So over here, using the Simpson rule, you're going to have the integral of cosine x squared from 0 to 1 approximated by s4. You're going to use delta x divided by 3. The first and the last one will have coefficient 1. So the first and the last one, which is f of x0 and f of x4, will have coefficient 1. So f of x0 and f of x4. For the middle term, you will alternate between 4 and 2. Let's remember to start with 4. So this is 4, this is 2, and this is 4. So you're going to have 4 f of x1, and then after 4, you're going to have 2. So you're going to have 2 f of x2, and you're going to have 4 f of x3. And because the last one is x4, so you just stop here. You don't have to alternate more. Okay, so I bring it over here. I put the plus sign. Okay. And delta x is 0.25 divided by 3. F of x0 is f of 0. F of x1 is f of 0.25. F of x2 is f of 0.5. And then you have f of 0.75, and then you have f of 1. Okay, and then you just need to plug in to your function. Okay, f of 0 is cosine of 0 squared. F4 cosine of 0.25 squared. And then you have 2 cosine of 0.5 squared. F4 cosine of 0.75 squared. You have cosine of 1 squared. Okay, and again, you can use calculators to get the final result. So this is the ideas of the Simpson rule, the trapezoid rule, and the left endpoint rule. For the next question, the question wants you to find n. The question wants you to find n. The question wants you to estimate the errors of trapezoid rule and S for the Simpson rule. They want you to know. They want you to find how many trapezoid you need to use to make sure that the errors in your approximation will be less than 0.001. The same thing, the question wants you to know how many points you want to use for the Simpson rule so that your approximation, the errors in your approximation will be less than 0.001. So this one is quite similar to the question that I mentioned in the lectures video. So I just copy down the solutions again. And you can use the idea to solve the problem. And to do this problem, you have to know the theorems over here. Sorry, the theorems for the errors in your approximation. Okay, so this is the theorem you need to use for this problem. Okay, so remember this theorem. Okay, and to save time, I will not solve the problems again. You just need to rewatch the videos in the lectures videos if you will not get the ideas of the errors in approximation. Okay, so in the next video, I will continue with the some more problems in improper integral.